So there's a variety of reasons why you might want to manipulate relative wind, why you might want your relative wind to be coming from a certain direction at a certain speed. The first and most obvious reason is flight ops. And flight ops isn't just for the military. If you have a medevac situation on your ship, or any situation that would involve a helicopter coming over, probably a medevac, but it could be other things. You're gonna need obviously need to prepare for them to land on your deck, or sometimes in medevac they don't land, but they'll just drop down, have their rescue diver like hook up to someone and pull them up with them. Either way, helicopters require the wind to be certain conditions, the relative wind, to make them most favorable so that the helicopter can maneuver into position. That's more their problem than ours. Why that's the case, I couldn't explain it to you, but helicopters need certain wind conditions to move slowly alongside a ship. But it's not just that. Let's say you're lowering a boat into the water, whether it be a lifeboat or a small boat, or whatever it might be. You're going to need to provide a lee for them. You're going to want certain conditions available for them to be able to actually get into the water without immediately being thrown into the ship by the wind, or potentially away from the ship way too fast. Things like that. There's on the training ship, another reason was just because every day the engineers would blow the stacks to clean them out by just sending pressurized air through them, and that would send a huge puff of smog, because the ship was decades old, out of the stack, and it would be terrible for the paint if it landed on the ship. It's also terrible for the turtles and stuff, but that's not we didn't worry about that. Anyway, you would need to maneuver when that was happening to put the relative wind on your beam. That way the smoke would go away from the ship and wouldn't land on it. So there's a couple different situations where you would need to play with what your relative wind is doing. And like I said, you could do that on a wind wheel. You could do that with Bowditch. You could do it by eye, because you can generally figure out, if I come left, will the relative wind go this way or this way? If I change speed, what will it do? But here's how we're going to do it on a MoBoard. Now, step one is, after obviously you have to find true wind to do that. So this first thing we did is just in preparation for that. Now that you have your true wind direction, what you're going to do is you're going to actually extend it out to the other side of the MoBoard, all the way. Like that. And then once you've got it on this side of the page, at the end, you don't need to do this, but it helps, draw out a little ship, kind of a virtual ship, just so that you can visualize and imagine your ship headed straight into the true wind, not in whatever course it's currently going, but straight into the true wind. And if you need to, you can also label port starboard. In this situation, let's say we wanted, we had it on the port bow here. Let's say we're doing flight ops, and the helicopter wants, I think it's 30 degrees on the port bow, but we're going to do starboard for this one. 30 degrees on the starboard bow. They want our relative wind to be 30 degrees on the starboard bow at usually 10, 15 knots. So let's say 15 knots. So we want the relative wind, 30 degrees on the starboard bow, hitting us at 15 knots. So step one, you mark out 30 degrees away. So if we're coming right around 118, 10 degrees away would be 108, 098, 088 would be 30 degrees away. So you mark out that line, like so. And then what you're going to do is you're going to mark the speed of the relative wind coming away from the center. So we want 15 knots. Let's make it 20. No, 15's fine. We want 15 knots, so it's right there. Mark that. By the way, If you're wondering why we're not doing it in the exact same way that we did contact avoidance, where you just swing the arc around and or you find a new DRM, line it up with your EM, then swing the arc to find what your course should be. The reason we're not doing that is because when you're setting your relative wind, you need to be manipulating both wind and speed, or both course and speed at the same time for a very specific value. Because when we're doing contact avoidance, we don't care how fast the relative motion is. We just care that the relative motion is along a certain line. It could be 10 knots along the DRM, or it could be 40 knots along the DRM. It doesn't actually matter to us. As long as it stays on that DRM, it's not going to hit us. In this situation, though, we need an exact course for the wind and an exact speed for the wind. And it makes what we do a lot more restrictive. You can't play with it as much. You don't get to choose what your exact course you want to be. It has to be, you'll see one of two options every time. Sometimes one of those two options isn't even available. Sometimes no options are mathematically possible. But at most, you'll get two options. And this method is the way to find them. You can't choose anything else. So we've placed our relative wind on the starboard bow, 30 degrees on the bow at 15 knots. Now what we do is we take the vector of the true wind, like that length, and we're going to swing an arc around, starting from here, passing through the true wind line we set. I wish I had the compass, but we don't. So we'll just try to swing an arc as best we can. So most of the arc doesn't matter, but it passed through here and here. You connect the dots from that point to each of the points where the arc passed through the true wind line, like that. And now those angles from here to there, we'll label this ER, both of them. From here to here are our two possible courses we could follow. So if we measure it out, we could go um 258, or we could go 159. Now for speeds, what you do is you measure the distance from the center of the scope to this intersection. And you can see, because obviously one has to be more than the other, the way these are categorized is the low speed solution and the high speed solution. So the low speed solution, if we measure it out, is 4.5 knots. So I'll label it right here, 4.5. And the high speed solution is 21.5 knots, 21.5. Okay, so to recap, if the true wind is coming from 288 at 12 knots, and you want your relative wind to be 15 degrees on the starboard bow, you can either sail on course 258 at 4.5 knots, or course 158 or 159 at 21.5 knots. And both of those will, if you did the vector triangle, work out to give you a relative wind on your starboard bow at 30 degrees at 15 knots. Now, the fact that it always gives you two options is important because they're not always realistic. I mean, think about it. Your two options here are less than 5 knots and more than 20 knots. Not every ship can manage both. If you're a warship, more than 20 knots is not a problem. It's whatever. Less than 4.5 knots might be less than bare steerage way, though, especially if you're in relatively heavy seas, which, what did we say, 15 or 12 knots of wind isn't really heavy seas. But if you were in heavy seas, going 4.5 knots wouldn't be fast enough for you to stay on course. So that might not be realistic. Alternatively, you could be like a massive tanker, in which case 21.5 knots is potentially completely impossible. It's just way too fast for the ship to actually manage. So 4.5 knots would be its only option. So the high speed and the low speed solution, it's going to depend on which one is logically more valid of an option. It could also be like if both are possible, maybe the course you need to sail for the high speed solution takes you really far away from track, and so you don't want to go that fast. And the low speed solution keeps you closer to the track line. Alternatively, maybe the high speed solution happens to be in generally the same direction as your course line, and the low speed doesn't, in which case maybe it's better to go the high speed solution. There's a lot of different options here, or reasons why one might be better than the other. Just know that you'll always get two options. Not always. If we moved the relative wind over to like 60 degrees and said we wanted the relative wind to be 60 degrees on the bow at 15 knots, you can see at that rate, swinging the arc wouldn't actually reach the line anywhere. And what that means is it's not mathematically possible to have relative wind 60 degrees on the starboard bow at 15 knots if the true wind is 288 at 12 knots. It's just not, it can't be reached. That, like, if you were asked to do that, it wouldn't be fulfillable. You could also somehow get it perfectly tangent, where it only passes through one exact point, in which case, okay, there's only one solution. Usually there's two, if any. So let's try it on the second problem, or actually the first problem, just to review that real quick. I'm going to erase this triangle because it wasn't necessary. So in this case, remember our true wind was 221 at 14 knots. So let's say we want it 10 degrees on the port bow at 20 knots. Let's just see what happens. 10 degrees on the port bow at 20 knots. So we extend the line. Out that way. Okay. We draw the sorry, you can't see. We draw the ship. Remember, here's the port side, here's the starboard side. So we are at 042, so 10 degrees would be 052. So we now draw the line 10 degrees on our port bow. And we wanted, I think I said 20 knots. So 20 knots, because we're still using the 5 times scale here. 20 knots will pass through here. Okay, our true wind speed was 14 knots, and it's obviously the same length as this vector. So you measure out this vector, and we swing the arc there and there. You get a point that passes through here, a point that passes through there. Now we connect the dots. There. And there. Remember, it's E to R prime, whichever one you pick. So we'll start with the low speed solution and just measure its course here. You can see the low speed solution would be to sail on course 235, course 235, and the high speed solution is to sail on course 029. Now let's check the speeds. The low speed solution would be course, what did I say? 235 at a speed of 6 knots. Okay. 6 knots. Slow, but not impossible. The high speed solution is on speed 27 knots. 27 knots. Okay, so unless you're a very specific type of ship, this is not happening. The overwhelming majority of cargo ships are not reaching that speed. You'd have to be a destroyer. You'd have to be like a high-speed catamaran, a ferry or something. A container ship is not going 27 knots. Meaning, in this situation, if you needed the wind, 10 degrees on your port bow at 20 knots, you've got to be going on course 235 at 6 knots. That's your only option.